So I just want to define some notions in this video. And I want to talk about some types of resolutions that I want to use. So we're going to take x over r to be a scheme. Here r is going to look like so some p-typical width vectors of k, and then we'll take k to be a perfect field with characteristic of k being p. And so, okay, that's all I want to say. So let me give a definition. So a Neron smoothening. Smoothening is a morphism. Let's say h from x prime to x, such that where x prime is smooth, let's say it's a scheme over R, which is smooth, and satisfies and is called let's say weak, intermediate, or strong, depending on the following conditions. Okay, so we'll say that it's weak if we just have a surjection on the FP bar points, so the width vectors. Okay, so this means surjection, the double arrow here. So intermediate. Okay, so I'm going to do increasingly stronger conditions. So we'll take the p-jet space of x, and we'll take it over. We'll take its special fiber, its geometric special fiber, and we'll ask that this surjects onto. Okay, and then we'll say that it's strong if we have a surjection just on, so that we just have a surjection on these topological spaces here. Okay. So we have this Neron smoothening is kind of like a resolution of singularities, right? So what you should think of as a resolution of singularities, where these things are kind of replacements. These are various replacements. So the idea is these are various replacements for the notion of proper. Okay, so this is kind of so let me just make some remarks here. So there's this Neron models book. So let me make some remark here. So a version of weak smoothings, appears in this book by BLR. A version of let's say weak Neron smoothening. Appears in this Neron models book by BLR. So then a modified version of this BLR weak Neron smoothening, which I think they just call a Neron smoothening, is it appears in a paper of Nikkei's. Paper due to Nikkei's. And then okay, and so then this version, so this version here is distinct from both. And if people want to know, I can maybe explain how they're related. All right.